Okay, so question 19 comes in a few parts. Part 1 first wants me to sketch these two graphs onto a single diagram. So there's a few things I should note before I do anything with this. The first, of course, is if I look at this, I should try and identify what these two types of graphs are. So if I look at it, this is going to be a rectangular hyperbola, right? Because I've got a linear term in x on the top line and a linear term in x on the bottom line. I'm going to have an asymptote when this bottom line equals to 0, so at x equals to 1. And I'm also going to have a horizontal asymptote that happens as x gets very, very large. I can ignore the plus 3 and the minus 1. I get 7x over 7. I'll have a horizontal asymptote at y equals to 7x divided by x, which is just 7. So this one's a rectangular hyperbola with asymptotes y equals to 7, x equals to 1. What about this one? Well, this one has is polynomial and has x here and an x squared term here, so it's a cubic equation. So what my two graphs should look like, this one here should look something like this with asymptotes. And this one here is a cubic, so it should look something like that. All right. So now that I know roughly what I'm doing, I should go to my graphing calculator. Now I don't have a GC here, but I've got something called GeoGebra, which will do pretty much the same job. And I'm just going to key in the equations on my two lines. So y equals to 7x plus 3 divided by x minus 1. And that's the graph that I get. And you can kind of see some of the features here where there's a very steep line. It gets very steep around here, and that's going to be my x equals to 1 asymptote. And it's also very flat here, and that will be my y equals to 7 asymptote. And then my second graph was y equals to x times x minus 1 to the power of 2. So if I look at this, what do I see? You may need to zoom in to see some of the finer details. So, well, let's just do that. Zoom in. And you can see here that it's got a x-intercept at 0, x-intercept at 1, it's got a turning point somewhere in between the two of them, not entirely sure where. And then it's got that same curvy shape that we were talking about, right? Okay, so this is roughly what I'm going to be sketching. I don't need to worry too much about the details, but there is one other detail I should care about, because I think I'm asked to look at it. Hold on, let's just see. I have to show clearly the coordinates of the points of intersection with the axes, so not with each other. Okay, so it should be fine. But I would just note, if I can, the intersection points here and here. So yeah, try to be aware of them at least, that you can see where those intersection points are. So this is roughly what the graph looks like. So I'm going to sketch it in here. Now obviously I'm not using it's a little bit hard on the computer, so just forgive me for some inaccuracies. Here we go. So this will be my asymptote, my vertical asymptote, x equals to 1. And then I've got a horizontal asymptote at y equals to 7. Obviously, you've got rulers and all that you can use, and it'll be a lot easier for you, so I don't expect any lines that look quite this messy. Yikes, that's terrible. Well, and then, oh yes, I should also find out the equations where they intersect the axes. That's not too hard, so you think about it. What happens to this one when x equals to 0? So x equals to 0 is the y asymptote. These terms become 0. I get 3 over negative 1. So minus 3 will be my intercept. So this will be 0 minus 3. And what happens when y equals to 0? Well, when y equals to 0, it must mean the top line equals to 0. It means that 7x plus 3 equals to 0. It means that x is equal to negative 3 over 7. So key that in here. Negative 3 over 7, 0. You may ask, why am I expressing these as coordinates? Because that tells me to, right? So I can't just express them as points. So I've got my asymptotes, I've got my intercepts. I'm ready to try and draw this curve now, so this will be a little bit tricky, but let's try it. Bang, bang. Wow. Okay, that worked. Now, some things to pay attention to for you guys. Make sure that your curve is always getting closer to the asymptote. It shouldn't like become parallel to it. It shouldn't, a fixed distance way, nor should it cross the asymptote, nor should it flick back away from the asymptote. Make sure it's always getting closer. And we're going to try and do the same thing over here. I hope. Not quite as nice, but you get the idea. So it looks something like that. So with this one, remember what we saw? We saw intersection points at 0, 0 and 0, 1. So this is 0, 0. This is, sorry, 1, 0, not 0, 1. And we saw a turning point around here somewhere, so I'm just going to sketch it in as best I can. Again, please forgive me. This won't be my neatest work. Right, there we go. So the graph looked something like that. I'm not asked to find the maxima or minima, so I don't need to. I can tell you that one already, though. That's not too hard. But yeah, so this is enough. So I've shown clearly the equations of my two asymptotes and the coordinates of the points of intersection with the axes. So this is sufficient for me. I am done with this part. No, I'm not. There is one thing I had forgotten to do. That's, of course, all my labels. So I should label my axes, x and y, and then I should label my curves, y equals to 7x plus 3 over x minus 1, and y equals to x minus 1 squared. So yeah, please don't forget your labels either. Now I'm actually done.